Now, since we have the force broken up into components, it is natural to talk about the work in the x direction and the work in the y direction. Now, this is still force times distance, except the force that you have to take into consideration is the force in the x direction and the displacement in the x direction, force in the y direction and displacement in the y direction. In these cases, you don't have to apply the cosine theta over here, and the reason is because the cosine theta is there in order to break apart stuff into its components. So if we've already done it, there's no need to do it. You can just work with components. So if we expand this, you can see that this distance here is all in the x direction, so we can call this displacement s subscript x. And what we get for this work is literally force in the x direction, which you can calculate. It is this vector over here, and displacement in the x direction. So this will give us the work in the x direction. Okay, looks pretty good. Now, if we go to the y direction, we still have a force in the y direction. This is kind of the weight of your hands pushing down onto the cart. The different thing here is that the shopping cart cannot move up or down. There is no displacement in the sy direction. It is blocked by the floor, and the cart is not going to fly up any direction. So the displacement here, sy, is actually equal to 0. So you multiply 0, and you can see actually that the work done in the y direction is 0. So that is a little bit of a difference here between the two components when you have a vector that is pointing in a different direction than your displacement vector.